pull you guys 2 seats to sit back here.
Oh, thank you.
Thank you. Hello. We're at capacity, actually.
Okay. Here.
Thank you. There's a father and a son, I think, that are the ones waiting for these 2 seats. And we'll seat them next to the accessible chairs. Perfect. You two right here, we got these spots for you. We'll put them right there for you guys. Perfect. All right. Do you have a seat? Great. Do you have a seat, man? Are you sure? Are you sure? Okay. Of course. On, Matthew. It wasn't on. He's back there going, and I'm like, oh. Could you please raise your hand if there's an empty seat next to you that no one is sitting in? We've got about 5 people over there that would like to see if we can pick. We've got 1, 3, 5. Okay, there are about 7 seats. Thank you. Hello, it's Maria again, disembodied voice in the back. Please raise your hand if you have a free seat. We've got everybody coming in. There are free seats, those of you who are coming in, and if you want a seat, there are people who have their raised hands, have a spot next to them. You may not be able to sit with your party, but if you want a chair, you're welcome to have one. There's one right here. We've got one right here. One over here, if y'all want a seat, there's one chair down here. We've got 2 right here if there's a party of 2 that would like to sit together. There are 2 chairs. There are also 2 over there. Some of you are refusing to sit and want to stand, and that's okay. If you don't want a chair and you're happy standing, now's your last chance. I'm going to introduce Graham, which means you're not allowed to move after this. Okay, last call, 2 chairs right here if y'all want to sit together. Welcome. Thank you so much for coming tonight. It means so much to us. My name is Maria Aschenbrenner, and I'm one half of the adult programs here at the Denver Museum of Nature and Science, which means that I put on all kinds of programs. We put on parties, we put on lectures like this free to the public. We put on like slightly higher elevated lectures that have a slight price point, higher price point than a free lecture does. And it is with great pleasure that I get to host 60 Minutes every single month. And it means that I get to know my regulars quite a bit, and I'm delighted to see so many new faces here tonight. With that being said, how many of you are here for 60 Minutes in Space for the very first time ever in your life? Insane. Give yourselves a round of applause. That's like solidly half the crowd, if not a little more. I'm very proud of you all for coming here and joining us. I'm hoping that a little bit extra sunshine got you guys out of the house to join us this month. How many of you guys attend 60 Minutes regularly? The ones that know my name, the ones that I may know your faces pretty well. Thank you for coming again. You hear my spiel every single month or every other month, and you're not tired of me yet. And I'm very happy about that. You may notice Kachun is not here today. Who? Where? He's gone. I don't know. So we had to find someone else. And I, he's the backup. Don't worry, y'all. Graham's real good with my humor. No, but Dr. Graham Lau is here speaking with us tonight, and he'll give a much better introduction about who he is than I could ever do for him. But I just want to let you all know that this is one of the best attended 60 Minutes in Space tonight. And so give yourselves a big round of applause for being here and joining us. Without much further ado, Dr. Graham Lau.
Awesome. Thank you, Maria. Thank you all for coming. For those who are new to 60 Minutes in Space, I am not the regular, as was mentioned. I am the backup, but I love being the backup. I was just getting my beard trimmed yesterday, and my barber, I was telling him I'm going to give this really cool talk at the museum tomorrow night, and it'll cover things like rockets and their history and space flight, and we're going to talk about aliens, both real science about aliens and science and the aliens in TV and movies. And he's like, dude, that sounds so cool. I never hear about this stuff. And I was almost brokenhearted. I was like, really? He's like, yeah, like, no one talks about space right now. He's like, all I hear in the news is all the stuff going on in the world, and there's a lot of stuff going on in the world right now. So I just want to say I appreciate all of you being here for an hour with me to talk about some things that are in our world, but also just to nerd out on some cool stuff about space and take a break from all of that for a minute. But we are going to talk about some cool stuff like rockets and aliens and all of this. And the first cool thing is that this year is a really important year in the history of spaceflight. This month marks 100 years since the very first launch of a liquid-fueled rocket by Robert Goddard. That's him in that picture over there. That's actually from 1925 as they were prepping the rocket. You can see it's nothing like the giant SpaceX rockets we see now, or the Space Launch System, or some other big rockets you might see. It started off a little simple trying to figure out how to make this work. The history of rocketry is long. Let me move that up a little bit. The history of rocketry has a very long story. I'm not going to tell you all of it because we could talk about that for hours. But by about 400 to 200 BCE, people were already thinking, like, how can we make things go a little faster? They started working on things like steam-propelled rockets, making water boil inside of metal canisters and seeing that as the steam was flying out, it was pushing the canister forward. The ancient Chinese, around 200 BCE, were putting pieces of bamboo into fires so they would explode. They realized the pressure was building up inside of the bamboo and causing it to make a firecracker. But the big step forward was gunpowder. Gunpowder, if you don't know, and this is really, really important if there's ever like a zombie apocalypse or like, I don't know, World War III breaks out tomorrow, and you want to make some gunpowder, it is 75% saltpeter, which is potassium nitrate, mixed with 15% charcoal and 10% sulfur. That's the formula. And getting there was really, really, really important for humanity. Obviously, it's led to a lot of atrocities in our history, but it's also very important for how we learned about chemistry. And so around the year 100 to 200 or so, we do have some early record of ancient Chinese potentially finding the formula, how to mix things together to make an explosive substance. We don't know for sure if it was gunpowder early on like that. We do know that by about the 9th century, that these ancient Chinese alchemists came upon that formula, that specific mix of 75, 15, and 10, coming together of saltpeter, charcoal, and sulfur to make gunpowder. And then everything changed. Then they had fire arrows. By the year 900, the ancient Chinese had developed the fire arrow, an arrow with a rocket on the end that could explode with gunpowder and burn. This idea of gunpowder making fireworks happened shortly thereafter, but also gunpowder started traversing the entire planet, and within a few hundred years, we had the development of guns and cannons and all of these other incredible things leading up to modern rocketry and its birth by the late 1800s, early 1900s. A few people who are important in that process. One of them we don't really talk about very often, but we should. He was a Peruvian scientist and a statesperson named Pedro Paley. He claimed that in 1895 he had tested a liquid-fueled rocket long before Goddard's flight, but he didn't really share that with others until some 30 years later, and we don't really know for sure if he actually did test this or not, but a lot of people do think, at least in his early work, even if he didn't fly a liquid-fueled rocket, he was thinking about building liquid-fueled rockets before Goddard. The guy in the middle is Konstantin Tsiolkovsky. In the Soviet Union, he was very much the father of rocketry there. He was thinking about what alien life might be like, how we might travel to other worlds, how humans might inhabit the moon one day. And he started thinking of how we could make liquid-fueled rockets. He never launched his own, but in the late 1800s, early 1900s, he was also in that vein of thought. And then we have Hermann Oberth on the very end here. He was a German scientist who, by the end of the First World War, was arguing that Germany should develop liquid-fueled rockets. It wasn't until after Goddard's first flight that he flew his own first liquid-fueled rocket, but he also famously was part of the Nazi program to develop the V-2 rocket, a very terrible machine of atrocities of war that eventually became part of our space program. Oberth, later in his life, came to the US, to the Redstone Arsenal. He joined Wernher von Braun and was part of an important step for America building our rocket program. All three of these guys are very important in the history. There's many others who are important in the history as well. But the one that we're celebrating this year is Robert Goddard and his launch. This image was created by a friend of mine, Charles Slatkin. Charles and his wife, they purchased Robert Goddard's childhood home, where Goddard lived later in life with his wife, Esther. And they've now turned it into a museum of Robert Goddard. So you can go to the Robert and Esther Goddard house in Massachusetts. You can see where he was raised and where he spent a good portion of his life later on. But without this happening, without this idea of a liquid-fueled rocket coming, we might not have gotten to where we are right now. We needed that step in history. There are reasons for it. Having a solid fuel inside of your rocket can also work. We did that with the space shuttle. We had solid rocket boosters on the side of the space shuttle. Maybe some of you have made your own model rockets with these little solid rocket motors and you've launched them into the sky, but getting to a rocket engine with liquid is a big step. And that really opened up everything that followed on afterwards in space exploration. So we had the launch of Sputnik in 1957. We had the 1961 launch of Yuri Gagarin, the first human in space. Of course, the Saturn V rocket that took us to the moon. This is the Apollo 11 mission launching, and then many, many flights of the space shuttle and other rockets. Nowadays, we have rockets launching all the time. There's so much mass going to orbit. SpaceX has become super successful. They are constantly launching rockets for all kinds of reasons. And some of you might know, we have a really big launch coming here pretty soon. The Artemis II launch is about to happen. This rocket is the Space Launch System. Much like the space shuttle, it has solid fueled rockets on the side that will help it to move really fast off the launch pad as much as it can for as heavy as it is, but it's also going to have a lot of liquid fueled rocket inside of it thanks to Robert Goddard. It's supposed to launch on April 1st, April Fool's Day. Hopefully that's not a joke. This image is not from the current setup. It is back on the launch pad, by the way. They wheeled it back out. It's ready to go for April 1st for a launch. This image is from February, though, and it's just such a cool pic because someone got the moon in the background. And if you don't know, the Artemis program is now our attempt, for the US government at least, for NASA, to get humans back to the moon. And so it's been a long time since we've been there. It was 1972 is the last time humans were on the moon. This mission is going to be pretty incredible. So the 4 astronauts who are going on Artemis II will be the very first humans to leave the Earth and go out to the moon and go around it. They're going to orbit around it again. It'll be very similar to the Apollo 8 mission. It never landed. It just went around the moon. They famously saw the Earthrise image, the first humans to see the Earth rise above the limb of the moon with their own eyes. These 4 astronauts will also set a new record on this flight. they're going to go further from the Earth than any humans ever have. If you've ever seen like the Apollo 13 movie, you might know that there was a disaster on that mission. During Apollo 13, to get that crew home safely, we ended up having to use the gravity of the moon to swing them back around and get them back to Earth with limited power and resources. And so the Apollo 13 astronauts currently hold the record for the furthest we've gone. They actually went a little bit further than intended out around the moon and back around again. This mission will go even further away, which is a huge step. But you might have been paying attention to the space news, since we are spacey nerds in this room, it seems. Maybe you heard that yesterday and today some big announcements have come from NASA. The current NASA administrator is fairly new. His name is Jared Isaacman. Jared is one of those billionaires who likes to have his own jets and airplanes. He's also now flown into space a couple of times. He had the Inspiration 4 mission that took several people along with him. He's now had the Polaris Dawn mission. He's working more to get humans into space for both space tourism and for NASA's plans. But with yesterday's announcement, we're now going to be restructuring the plan for Artemis and getting back to the moon. Originally, the Artemis plan was with Artemis 2 to go around the moon, and then with Artemis 3 to land on the moon, and then after that is to start building a giant space station around the moon called Gateway. Yesterday, they announced all of that is changing. So we're restructuring the entire program. One of the first big things is they've decided to scrap that space station around the moon. So it was called Lunar Gateway. The idea as of yesterday now is to stop everything on production on that, put a total pause on development of that space station, instead to take all of the work done so far for it, along with $20 billion over 7 years, and then another $10 billion on top of that a few years after, to start building a lunar space station, a lunar infrastructure that NASA intends to build. Also, they announced that we're going to change the structure of the Artemis launches. If, hopefully, everything goes right with Artemis 2 and it's successful, the plan for Artemis 3 next year is to go into low Earth orbit. That's LEO, is low Earth orbit, means close to the Earth. The plan there is to work with all the industry that we have, like SpaceX and Boeing and all these other companies, and figure out all the technologies that we're going to use in landing on the moon. Because as of right now, we don't really know who and what companies are involved in the landing process of getting us onto the moon. For instance, I tossed in a picture here of a SpaceX rocket landing on the moon. We don't really know what the total infrastructure is going to look like in getting there. And so Artemis 3, the hope is to have that figured out so that then by 2028, we can land Artemis 4 with astronauts on the surface of the moon. Jared is a billionaire, and so not one to avoid audacious statements. He said after that, we want to plan for a launch every 6 months thereafter. That is a very incredible time scale if that works. But it would be pretty cool to see us going back to the moon like that. One of my favorite things, though, we heard yesterday, is that going beyond the moon is a plan to launch this Space Reactor 1, or SR1, they're calling Freedom, which that's just an artist's representation of what it could look like, I guess. The idea is in 2028 is to launch the first nuclear engine, first nuclear electric engine fueled spacecraft to go to Mars, and then release a payload called Skyfall. Some of you might have seen the Ingenuity drone that was flying around on Mars. When we landed the Perseverance rover on Mars, we had a little drone that went along with it called Jenny, or Ingenuity, and that drone was so successful. It made so many flights before it finally died. And so the idea with Skyfall is to put a whole bunch of those drones, they haven't said how many, but a bunch of those drones in different places, and have them fly off and do a bunch of cool science on the surface of Mars. I'm very excited about this potential of using a nuclear-fueled electric engine. Some people worry about sending nuclear into space. Just so you know, we have done that several times already. So Perseverance and Curiosity, the rovers on Mars right now, they are nuclear generator powered spacecraft. Voyager 1, Voyager 2 have nuclear capsules inside of them that help them create energy. So this could be a big step for space exploration. Nuclear electric engines can produce a lot of energy. And so this would just be a very first test. It's like a 20 kilowatt, very small nuclear test engine, but it could really change a lot in space flight. And by the way, for 60 Minutes in Space, we do jump around a bunch, at least when I'm doing it. And so I love doing things like numbers of things happening in space. So every time you see me here, we're going to cover just some random space numbers about some current science or space exploration, all the things that I think are cool, some things you might not have heard of before that are just awesome to talk about. Let's start off with some satellites, but some natural satellites. And just so you know, a satellite is any body that orbits around another body. And so moons are natural satellites. And just this month, we now have a new announcement on the number of moons around the giant planets of our solar system. We now have 101 moons around Jupiter and 285 moons around Saturn. Did you guys know that? I didn't. I knew the numbers were huge, so I'll tell you, I love talking about space and about space science. There's a few things where, like, as a science communicator, you memorize certain numbers. This is one where I just gave up years ago because we keep finding more of these moons, and they're really small. They're small, rocky things. They have weird orbits. You know, we found all the big ones. The big ones were easy. Galileo found the very first 4 moons outside of our own around Jupiter. He found Io, Europa, Ganymede, and Callisto, but now we're still finding more. We found 4 new around Jupiter and 11 new around Saturn this year. And so that's pretty crazy. And I don't know how any of us can keep track of it, but if someone asks you how many moons do these planets have, you can just say hundreds. It's an easy guess. But these are natural satellites. And so 101 natural satellites around Jupiter, 285 natural satellites around Saturn. We have one major natural satellite around the Earth. There are every now and then like a small body, like an asteroid, gets locked in orbit with Earth for a while, and we'll have like a mini moon for a little bit. Doesn't happen very often. Does anyone want to guess how many active satellites, like artificial satellites, we have right now? A lot. A lot is a really good answer, yeah. Oh, 15,000. Wow, that is on the money. 14,959. You're off by 41. That was a really, really good guess. As of right now, we have about 15,000 active satellites around our planet. This is an image from NASA's. It's a scientific visualization working group they have at NASA Goddard, named after Robert Goddard. They create really incredible graphics. You can download these videos for free and use them, teach with them. They're fantastic. This is from last year, showing all of the tracked orbital objects that we have around the Earth right now, at least that NASA and NASA associates are tracking. And so you can kind of get a visual field here. There's this big kind of ring on the outside. Those are geostationary satellites. They stay in the same spot around the surface of our planet. They're part of why things like GPS work. They help us with a lot of mapping and data. There's also others in all kinds of weird polar orbits. Those are more rare, but we have a lot of satellites that are mapping our planet, and then boatloads in close for things like telecommunications, a lot of science going on, more Earth observation, things that are taking pictures all the time. There's some incredible things from Planet, and the company, I'm spacing the name right now, it used to be called Maxar. We have a couple of companies who are constantly taking images of the entire surface of our planet. We can now see things like natural disasters in live time and wildfire in live time. We also have things monitoring phytochemicals in our planet, the changes in ocean temperatures, ocean currents. There's so much that we're measuring in space. And then a good portion of these are military. They're defense satellites that are watching enemies and allies for various nations around the globe. The ones that are defense-related or now war-related, we don't really know what they're all doing, but they're out there. But that is not the total number of pieces of material that are orbiting around our planet right now. Right now, a good estimate is about 40,000 total objects are in orbit. Those include derelict and dead satellites, old things like that. It includes things that we've intentionally jettisoned from spacecraft in orbit or from the ISS that we know will crash into the atmosphere and burn up eventually. They include things like the nations, the US and Russia, India and China, who've now used missiles to blow up satellites in space. It includes debris from those explosions. And this graph down here is also from NASA. It ends at 2025. If it showed this year, it'd be another big spike going up as well, because we are sending more and more and more stuff into space. If all of the current proposals were to go through, then in the next 10 years, we would have something like 500,000 to 1 million pieces of material in space, and many of those would be active. And so we can talk. I will try to avoid any politics tonight, but I'm more than happy to talk about what some of these things mean for all of us. So for instance, Starlink from SpaceX is launching a lot of these satellites into orbit to create satellite-based Wi-Fi. There's good and bad there. The good is it can democratize the internet. It could bring people onto the internet to start sharing their stories from around the planet, from places that traditionally have not had access to the internet. We might soon hear new voices and new ideas from our fellow people from around the globe, and that's incredible. But it also means that we are clouding out the night sky. Everyone in this room right now is amongst the last generations of humans who could go outside on a dark night and look up and not see lights crisscrossing the sky everywhere. And that's a big problem for astronomy. A lot of our astronomy is ground-based. You know, some people like Musk and some others will say, well, just build more space telescopes. Building a space telescope costs billions, tens of billions of dollars sometimes. It can take many, many years, decades even. And it's not easy to do. Whereas we can do a lot of astronomy from the ground, and right now we're having the issue that a lot of astronomers are worried that we're going to soon not be able to do a lot of science anymore from the surface of the Earth. And that's a problem. Another issue that you might know about is this company called Reflect Orbital, and there's a few others like them right now planning this, would like to put giant mirrors in orbit of the Earth so that we can provide sunlight to the dark sides of the planet all the time. Their plan, if they go through, so they might not get the allowance to do this, but right now their plan is this year to launch 2 test satellites to do this. But then thereafter, they quickly want to ramp that production up. So by next year, 36, then 1,000, then 5,000, and then 50,000 mirrors pointing sunlight back towards the planet at all times. Now, they've done some studies, and the studies do appear to show that they can constrain the light to be fairly narrow bands, so it would just shine in one little area. They want to charge a lot of money for this, for those who want to access that, primarily for agriculture and for solar energy, to have more constant light exposure. But there's just so much we don't know about what that would do. If there were 50,000 mirrors, giant mirrors, pointing sunlight back at the nighttime side of our planet, we might finally lose the night. And we humans rely on darkness. I need darkness to sleep. I don't like sleeping in the light. I can do it. It's not fun. I'm sure many of you are the same way. Like, I hate hotel lights. I have to put towels over the door light from the hallway and stuff like that. I need darkness to sleep. Many of us do, but at least we can reason through why it might be some light in the room. Like, we can't put our darn cell phones away, so it's light. But we share this planet with other creatures. There are a great many nocturnal creatures like owls and raccoons, skunks, luna moths, many insects actually, that require darkness to live. If we start shining light onto the planet's nighttime side all the time, we don't know what's going to happen to the ecosystems that rely on these cycles. And we call these diurnal cycles. Light and day cycles are diurnal. There are organisms that thrive in our ocean called phytoplankton. They produce most of our oxygen. They rely on diurnal cycles. They need darkness to go up and down in the water column. The things that eat them are called zooplankton. The things that eat those are called whales and fish. And so we don't know what's going to happen to the large-scale ecosystem of our planet if we start shining that much light down. And some of us are very concerned about it. And if you are as well, then let's chat later after this talk. But like I said, we do move through a lot of things in 60 minutes because that's a short time. And the next thing I want to talk about is all of that life on our planet we share this world with. Some of you might know my planetarium talk I've been giving for over a decade now called The Craziest Creatures on Earth, where we talk about just the weird things that life does. I mean, life really is incredible on our planet. And for me, as an astrobiologist, someone trying to figure out how this all happened and whether it happened somewhere else, I can tell you that we don't really know what life is. There's so much we don't know, and we don't even know how life started. We wonder sometimes, like, how did it all begin here on our planet? Did it all start on the planet? Did it start in little warm pools like Charles Darwin said, or maybe deep in the ocean? More recently, my colleagues Bruce Damer and Dave Deemer have argued that life can't start in oceans, that it needs dry land with drying and wetting cycles to occur. But also, maybe life came to our planet. There's an idea of panspermia, that life might be everywhere, and these seeds of life from space could come down and create life here. Maybe we're Venusians. Maybe we're Martians. We don't know, but we're learning more and more about where the basic building blocks of life as we know it come from. And there are some key biomolecules that you have, the things that make you up. You have proteins. Most of you is protein. And that's made by amino acids, a very simple chemical. They happen a lot in nature. You also have sugars inside of you, so some of your proteins like to make sugars. So you have sugars inside of you. The cells you have in your body rely on fats, lipids. And you have a lot of fat inside of you. And then we also have DNA, our DNA and our RNA. This is what codes the information. All of the information inside of your cell that says, this is how I make you, is written in RNA and DNA. And those molecules are formed by these 5 things called nucleobases. And so again, I love numbers. Here's one, 5. There are 5 nucleobases. These are nitrogen-rich molecules that make up the basis of your DNA and RNA. 2 of them have a couple of rings, and we call them purines. And then 3 of them have a single ring. All of them are carbon, nitrogen, oxygen, hydrogen mixed together. And so there have been some pretty cool findings recently you might have heard about in the news. And I'm going to play a little video here about one of those findings from last year. My friend Danny Glavin and some of his colleagues wrote a really cool paper with some new findings. And so we're going to watch a short, 4-minute video about these findings, and then I'll share some more about the more recent discoveries.
Scientists are looking beyond Earth to primitive asteroids like Bennu, the target of NASA's daring OSIRIS-REx sample return mission. Now, material from Bennu is revealing a lost world from the dawn of the solar system with the right conditions to foster the building blocks of life. When scientists examined the Bennu samples, they discovered evidence of a wet and salty past. Among the dark rocks were bright veins of salts that form on Earth when brines evaporate from alkaline lakes. Searles Lake, California is home to a mineral called trona, which is mined as a source of baking soda. Scientists found microcrystals of trona and other evaporite minerals within the Bennu samples, indicating that they once held pockets of sodium-rich water. Such brines are ideal for cooking up organic molecules, carbon-based compounds that are the stuff of life. Bennu is a carbon-rich asteroid, and its samples are chock full of organics, including amino acids and nucleobases. Amino acids can be bonded together in long chains to build proteins, which give cells their structure and function. Life is constructed from a set of 20 amino acids, 14 of which were identified within the Bennu samples. Nucleobases are the genetic components of DNA and RNA. All 5 nucleobases were discovered in the Bennu samples, a first for extraterrestrial material collected by a spacecraft. In addition to organic molecules, scientists found that the Bennu samples are surprisingly rich in ammonia. On Earth, ammonia is a common agricultural fertilizer. It readily evaporates at room temperature, but is more stable in cold environments, like those found in the outer solar system. Bennu is too close to the sun to retain pure ammonia, so its samples must have formed during a more distant, frigid past. Salts, organics, ammonia. Thanks to OSIRIS-REx, we can now piece together these clues to tell a likely origin story for asteroid Bennu. 4.5 billion years ago, in the nascent solar system's outer reaches, a world of rock, metal, and ice took shape. Radioactive decay heated its interior, melting some of the ice.
pockets of mineral-rich water reacted with formaldehyde and ammonia to produce organics. As the water dried up, the dissolved minerals crystallized, leaving bright veins within the rocks. The world migrated closer to the sun until it was shattered in a collision and destroyed. Bennu accreted from the rubble and drifted further inward, eventually settling into a near-Earth orbit where it could be reached by OSIRIS-REx. Our planet was bombarded by asteroids like Bennu early in its history, suggesting that many of the same organic molecules were present on Earth before the dawn of life. These findings help to close a gap in our understanding of the early solar system, but key questions remain open. Many amino acids can be created in two mirror image versions, like a pair of left and right hands. Life on Earth almost exclusively produces the left-handed variety, while the Bennu samples contain an equal mixture of both. This means that on early Earth, amino acids may have started out in an equal mixture as well. The reason that life turned left instead of right remains a mystery. Additional insights may come in 2030 when NASA's Europa Clipper mission arrives at Jupiter. It will hunt for evidence of a briny ocean within the moon Europa, an environment favorable to producing organics. Until then, scientists will dig deeper into the Bennu samples, unearthing more molecular clues about the origins of life.
All right, pretty awesome. So yeah, Bennu is a rock pile. It's a rubble pile, a pile of old material from the early solar system. One thing you didn't see in that video, they should have shown it. They showed the spacecraft coming in. They didn't catch the boop. There was a cosmic boop that happened when the spacecraft touched, and this little vacuum thing in the front of it sucked the material in and then brought it back to Earth. They found sugars. They found amino acids, and they found those nucleobases, the basis of RNA and DNA inside of that. And this wasn't super surprising. So we have meteorites across the planet, like my own little itty bitty piece of one right here I have. This is a piece of the Murchison meteorite, which is why I only have a small piece. It's a very famous meteorite. There's a few that we have in our collections that we know have amino acids and nucleic acids and sugars, all these basic building blocks for life as we know it. We found in meteorites. We've now found them on Bennu, and this picture is actually not Bennu. This is another rubble pile in space called Ryugu. And it also had a spacecraft go to it called Hayabusa 2, launched by the Japanese space agency. And a paper just came out this month online that they've now found the complete set of nucleobases in this asteroid as well. They also found sugars, they also found ammonia, they also found amino acids, all the stuff we expect. But the 5 nucleobases are pretty exceptional. But they're not quite the same mix of nucleobases. So remember earlier I mentioned that there's some called purines and some called pyrimidines. We can compare the ratios of those two kinds. So again, some the pyrimidines have the single ring, the purines have the double ring. We can measure the ratio of these to each other, and we can see that Ryugu has a lot more of the purine than Bennu does, or a meteorite called Orgay. The piece I have of Murchison is about the same, so the meteorites are much lower. Ryugu is much higher. And so in this paper, they're trying to explore the science. So like having the same kind of starting material, what might drive these differences? And they're thinking that the ammonia environment around these formation processes of going from what we call precursors, so things like cyanides and very basic carbon-containing molecules to make these larger structures, it might actually depend on the chemical environment around these materials as they form. There's still so much that we're learning. We're not really sure yet the process chemically. But I've seen a lot of stuff going around in social media, especially where people are like, oh, we found the nucleobases. That means there's DNA and RNA. That means that we came from aliens. That means aliens live on these things. And no. No. So DNA and RNA are exceptionally complex molecules. What we're finding is this little piece over here, the nitrogenous base. It's a piece of the molecules that make up DNA and RNA. It's called a nucleobase. But if we want to get to DNA and RNA, we have to go through a lot of chemical steps that are really, really difficult to do. And it's part of why in Origins of Life Science, we're not quite sure how we got there yet. One of those steps is putting on a sugar, a ribose sugar or a deoxyribose ribose sugar. DNA is deoxyribonucleic acid. To get there, you need a deoxyribose sugar. That's a nucleoside. And then on top of that, you need to figure out a way to add on a phosphate molecule on the outside, and then you get to be a nucleotide. But even then, you're still not DNA and RNA. You have to find a way to bring those things together into something like the DNA double helix. So inside of the DNA double helix, on the outside is where those sugars are at, kind of these branches on the outside. The little ladder in the middle is where the purines and pyrimidines are at, and they're bound to each other. They have chemical bonds holding them together. And on the outside, we also have the phosphate backbone, so that there's phosphate molecules attached to each other and hold everything together. It's a big step to get from nucleobases to life, but it's a pretty cool step all the same. And finding it in asteroids like Ryugu, like Bennu, like the Murchison meteorite that we have from space, it tells us that the basic building blocks for life as we know it are everywhere. And we found a lot of these things in space too, by the way, just out in space in clouds. We have a little bit of time left, and so I'm going to jump through a couple of things real quick here. First off, oh my gosh, what a year for aliens and sci-fi. If you're a nerd like me and you love sci-fi, there's so much going on right now. If you haven't heard, Project Hail Mary came out. It had an $80.5 million box office. Biggest box office so far this year. I haven't seen it yet. I really have to. My book club, we read it last month. I have over 70 pages of notes on the math and science in a Google Doc, and it's really, really good. I'm excited. I cried the first time I read the book, and I don't want to give anything away, but it's a really incredible story of sacrifice, of isolation, of how far you go to save a civilization, or even more, how far you might go to save two civilizations. Some other things happening right now. I have no idea what this is going to be. You might have seen the ad during the Super Bowl about Disclosure Day. It's a Spielberg film coming out this summer. Disclosure is the idea that the US government in particular, but also other world governments, have knowledge of UFOs and aliens being here on Earth and are hiding it. I'm really curious to know what's going to happen with this. I can't say much right now. Pluribus, oh my gosh, what a weird show. I love alien invasion sci-fi. I have a recent post I wrote in my Substack, and I think it was like 54 different alien invasion scenarios across science fiction. Pluribus presented a new fun one, that maybe the aliens won't travel through space and time, but will have us basically invade ourselves and become them in a very fun way. And the story plays through a character who doesn't become them. And then finally, The Dark Forest, season 2 of The Three-Body Problem is coming out here this summer. This comes from a trilogy of novels I just started reading last night, The Three-Body Problem. The second novel in the series is called The Dark Forest. And ideas from this story are now pervading the science of astrobiology. This idea of the dark forests, as presented by the author, imagine you're alone in a dark forest at night. You could cry out into the forest to see if anyone else is out there, but you don't know what else is out there. It could be creatures of the night that might want to harm you, or it could be that there are others in the forest who would choose to end your existence to avoid having themselves be preyed upon by the creatures of the forest. And so it's a really interesting idea. There's problems with it, but it's really now in our sci-fi. A couple more things from me. Some shameless plugs for my own stuff. I do have a book club. If you're interested in reading some books about alien life, astrobiology, the science, and science fiction, we're just now finishing this book called Time's Second Arrow. My friends Bob Hazen and Mike Wong wrote this book, basically exploring the laws of nature. Some of you here might know that entropy is the only law of nature that we have that's driven by time. The increase in entropy in the universe basically tells us that as time moves forward, disorder is increasing all the time. And right now in complexity science and in astrobiology, a lot of us wonder, how can life exist then? How can things become more complex in that situation if entropy is always driving that? And so they have proposed what they're calling the law of increasing functional information, that as information increases and is being selected by the universe, the more functional information there is, the more it drives even more functional information, and the universe is becoming more complex with time. Order is increasing with time. If you're interested in reading this book, like I said, my book club is finishing it, but I did get a discount code from the publisher to buy the book at 20% off, and so you're more than welcome to snap a shot real quick if you want and purchase the book before March 31st for 20% off. Mike Wong will be co-convening a session with me at AbSciCon, the Astrobiology Science Conference in May in Wisconsin. I'm trying to get him here to Colorado to do some cool science stuff. We'll see. And then Bob Hazen at Carnegie Institute is just an amazing scientist, been studying mineral evolution for a long time. One more plug for me, just so we have time for some Q&A. If you're in Boulder tomorrow night and you want to do something fun, come to Fisk Planetarium. I have a planetarium talk I'm doing on the mythologies of alien life. I will argue that not only is language our first technology, but that myth and science evolved together shortly thereafter. As soon as we could tell stories, we tried to find ways to make meaning and learn more about our place in the universe. And I wonder what that means alien life is doing as well. And so I think I'll finish right there, and then we can do some Q&A from everyone then after this. Thank you.
The most random question I've ever been asked. If you took an Uber here and lost your phone and are also wearing a white shirt, our security has it. Please come find me. Thank you.
Okay. Did everyone hear that? Yeah? If you
Took an Uber here and are wearing a white shirt and you lost your phone, come talk to me in the back, please.
Awesome. All right, we have plenty of time now for a few questions. It can be about anything I talked about or anything else. Right over here. What's the purpose of their mirrors? So the idea of these orbital mirrors from Reflect Orbital and other companies, and this has been an idea for quite some time in science fiction and in the real world. People have wanted to do this. The idea is to have these large orbital reflective mirrors that can capture sunlight from the other side of the planet and beam it around to the nighttime side of the planet. So money, profit. They want to make money, and they want to charge a boatload. I think it's like $5,000 per hour per some like unit. It's a lot. It's gonna be a lot of money, and so they're gonna charge millions of dollars to people to use this. The idea is to get solar power. So large solar generation stations could pay for this nonstop sunlight, and they could have power all the time. But then you also have some agricultural processes where they might want to do like vertical farming, and they could have sunlight shining down on top of the vertical farm nonstop. So there are reasons people want to do it, but the big drive is money. Right here. Oh, that's a fun question. So the question was, why is there a preponderance of left-handed amino acids? And also for life as we know it, it's mainly right-handed sugars. And so we kind of use a mix of the amino acids and sugars. So in nature, these different kinds of the handedness of these molecules go through racemization. It means they get mixed together, and there's usually like a 50-50 mix of all of them. So in Bennu, in Ryugu, in our meteorite pieces, it's a good mix of both of these isomers. We call them these different flavors or different handedness of these molecules, and we don't really know why life as we know it has picked a certain one for amino acids and a certain one for sugars. But there's also an issue is that life as we know it doesn't just use right-handed. It also uses some left-handed amino acids and some right-handed sugars. And so life as we know it isn't homogeneous for one or the other. It has a preferential excess towards one or the other. And there could be reasons for that come from photochemistry, from early chemical reactions on the Earth that drove just an abundance of one over the other. But life as we know it, once it starts going through various enzymatic reactions to create new proteins, it chooses only those certain amino acids of that flavor to bind together and make our proteins. There's an idea right now of mirror life. Some people are very afraid that we, in our synthetic biology laboratories, might make organisms that use entirely opposite machinery, and that mirror life might outcompete life as we know it. And so a paper came out, I think, a year or two ago, arguing that we should stop that until some researchers and ethicists have a chance to figure out what's going to happen. Right here in the middle? How do we stop the mirrors in space? So there was a commenting period. I think it closed like a week ago. There was a commenting period for the public to input their opinions about these mirrors in space. Now they're waiting for government clearance to allow them to start the process of launching the first two. I'm not sure if there's anything you can do right now to stop the mirrors. Right back here? Oh, that's a fun question. So the question is like, what are the scientific goals of Artemis 2? And there's a bunch. So Artemis 1 has already gone, by the way, in case you hadn't seen it. Artemis 1 sent a payload around the moon. My friend Luis Zea, who runs a company here in Colorado called Jaguar Space, had a payload on that. There's a bunch of payloads we can send to study things like gravitational dynamics going around the moon, various things we can do in microgravity experimentation, stuff like that. Much like with the Apollo astronauts, we can test the physiology changes for the astronauts. It's a 10-day trip for Artemis 2 to go out around the moon and back. During those 10 days, we can learn a lot about astronaut health. We have a lot more knowledge now of how to measure those things and how what to look for than we did during the Apollo missions. So you might have heard, for instance, like Mark and Scott Kelly did a twin study previously trying to understand what happens to astronauts, like their health and their eyeballs, their bones, their muscle tissue. I mean, all kinds of parts of our bodies are impacted by being in microgravity, high radiation environments, under stress of being isolated, and all this kind of thing. So there's a lot of human physiology studies and a lot of other experimentation we can do during Artemis 2. Yeah. The mirrors seem to be a hot topic. The mirrors are a hot topic.
I got two. So one is about like the impending, the Kepler effect and sort of the realism of what that looks like and your thoughts on that. And the second bit is, are there anybody who are like astrological meteorologists who are also like, if the mirrors become too much, then so too do we affect weather systems, like not only the ecology of the life, but also the systems of the warming and cooling of our planet? Yeah. Are there people who are engaged in what that looks like?
Yeah, so we had a two-part question. The first is, what about the Kessler syndrome? And I can mention what that is. And the second question is, like, what about the dynamics of our atmosphere with these mirror satellites in orbit? And yes, the mirrors are apparently a hot topic. So please go check it out and learn more for yourself and make your own opinions that are well supported. First off, the Kessler syndrome is an idea that's been around for some time. Who here has seen WALL-E, the movie WALL-E by Pixar? Fantastic. Watch WALL-E, everyone. Fantastic movie. I also cried to that. I cry a lot. But during WALL-E, there's a scene where this little robot in this animation goes out beyond Earth, and in the process has to fly through a giant just sphere of just junk, space junk everywhere. And it was kind of implying that at a point in our future, we might just put junk, so much of it in space that it just covers our planet. And this is based on real science called the Kessler syndrome. The idea is, so right now, like I mentioned, we have 4 nations so far that have launched missiles into space for the sole purpose of blowing up satellites. No one so far, to our knowledge, has blown up a satellite of another country. We always blow up our own satellites as tests, but we've done it. And in the process have blown debris out everywhere. And the idea here is that what happens if we have so much material in space that during one of these collisions or explosions, or if we go into warfare and people are throwing missiles at all these different satellites and things are blowing up, you start having debris flying everywhere, striking more satellites, breaking more debris out flying everywhere, and before you know it, we have a sphere of just debris everywhere, and we lose access to space for a very long time until orbital dynamics cause a lot of that to decay. It's a very real threat, and we honestly don't know if 10 years from now, like I said, if all the proposals we have right now go through with governments of the world, not just the US, but all the governments of the world, it's something in the range of 500,000 to 1 million satellites. And we just don't know. We don't know what that's gonna be like. We don't know what's gonna happen. I can say, like, the idea that like we can't launch a spacecraft to get around them isn't quite right. There is a lot of space out there, and satellites are very small. Even if the sunlight you see glinting off of Starlink satellites makes them look big, they're actually not that big themselves, and they don't take up a lot of space. And so we can still launch right now. Even with 1 million satellites, we could probably still launch pretty well. The question is what happens if we start breaking them down? And another place I can just say we don't know is on the dynamics of having giant mirrors in space, like 50,000 giant mirrors shining light into our atmosphere at night, what it might cause for changes in atmospheric chemistry, circulation patterns. I haven't heard anything from anyone studying that or exploring it yet. Phil Plait, who goes by the Bad Astronomer, or Bad Astronomy, he had a really good article out 2 weeks ago about reflectorbital and just the science that we do know of what could happen, but there's just so much we don't know. Yeah. Yeah, that Dumbo snail. It's a sea creature. Kind of looks like a giant Dumbo elephant. It's pretty cool. Yeah, there's so many weird creatures. Oh yeah, I'm sorry. So sorry. In the picture of all the animals, they had asked like, what was that weird thing down there in the bottom corner? And honestly, I just love all the sea life of our planet. There's incredible things in our ocean we don't even know exist yet. There's probably millions of species we have never seen before. Right here in the middle. To melt all the bad stuff? Well, we can put a lot of generators in space. One idea for a place like Europa, so in that video, you saw this idea of Europa Clipper. It's a mission we launched. It's going out to Jupiter and its moon Europa. It's going to get there in 2030. Europa is a moon that we're flying to learn more about. Europa is about the same size as our moon, and it has a really thick, icy crust on the surface, about 6 miles thick. And then down below that is a really, really, really deep ocean. And a lot of us want to know if there could be aliens living in that ocean. But the only way to really find out, at least the best way, is to get down through all that ice. And so one thing we're thinking of is melting down through that ice with a really high-powered, hot generator that melts through it. But when it comes to like killing anything out there that could be bad for us, there's a lot we don't know. We don't know if there is anything out there yet that could be bad for us. And so it's really important that we look. It's also why at NASA we have someone whose job is Planetary Protection Officer. And that's a really cool title. Yeah? Oh, Quinn. Are we able to turn off the satellites is the question. Yes and no. So we can turn off the activity of the satellite, but it's really hard to change where it's at in orbit. To make them cheap, they don't put fuel on the satellites, at least not most of them. And so they don't move around. They stay where they're at in orbit. And so even if we said, like, stop pointing sunlight at the Earth or stop taking pictures, it would still orbit for a really long time. Most of the satellites are far enough out, it takes years for them to fall back into the Earth. Yeah? How do we launch them into the air? Well, that's a cool question. So there's a reason why we like to launch from around the middle of the planet. So the equator of our planet, it's best to launch close to the equator, because then we can launch as the Earth is moving. We can launch with the Earth already moving, and that helps us launch with a little bit less fuel. Makes it pretty easy. And then because of people like Robert Goddard and a lot of really smart people over many generations working in a lot of different places, we've learned really well how to make rockets work. And we're pretty good at it, honestly. Yeah. Yeah, so the question is, how are other space agencies reacting to what we're doing right now with the Artemis program and the idea of changing Artemis now, and are other nations involved? Yes, other nations are very much involved. NASA never works by itself. NASA is always working with our partners around the world. JAXA, the Japanese Aerospace Exploration Agency, ISRO, the Indian Space Research Organization. We're not currently doing a lot with Roscosmos because of global issues right now and governance. But the Russian Space Agency we've worked with a lot in the past. We'll see if that changes again in the future. But we have many other partners. There's many nations that don't have like very large space agencies. Only a small number, about a dozen nations, have launch capabilities that can actually launch things into space. Many other nations are involved in space exploration, have their own satellites, are involved in building new materials, instruments, helping us get supplies for various things on the ISS and for the upcoming space station, or the lunar base. But there's always issues. There's always work we have to do together internationally for the engineers, the scientists, and then for those involved in government to make those contracts work. Yeah, so the question is about chemtrails. I can tell you, if you watch planes flying, they naturally make contrails. It's a natural process that occurs, and we do not have any evidence that there are chemicals being released by these things by the government that supports the idea of chemtrails. And certainly there are many people who believe that chemtrails are a real thing, and I'm happy to discuss that with you after this. But yeah, there's just no evidence that there's any government program of releasing any chemicals into our atmosphere. Yeah. Wow. Yeah, it's incredible. So basically, a personal story of this change that we've seen in time with not only our aircraft moving through our sky and so many of them. So we have Science in a Sphere here at DMNS. There's an incredible display on that shows just the very large jet airliners moving across the planet. At any given point in the day, there's many thousands of airplanes everywhere, but also the satellites. Like Sputnik was the first one, and it changed a lot of opinions. One, it got a lot of Americans interested in space exploration. They were like, oh my gosh, the Soviets can orbit the Earth. Now what? And so it really did change a lot. It started the space race, really. And then we had kind of the back and forth. And just, like, we love to be like, oh yeah, America, we're number one. We won because we got to the moon. But like, the Soviets did all the stuff first besides the moon. So they're the first satellite, the first person in space, the first woman in space. They kind of started kicking some butt and did a lot of really cool stuff. But they had their own issues, of course. And so we got to the moon with NASA. But fortunately now, since then, a lot has changed. There's a lot of collaboration, cooperation. But I will say, like right now, a lot of our drive has to do with China and what the Chinese Space Agency is doing. And they are moving very fast, and they are doing some incredible work in space exploration. But yeah, thank you for that story. Yeah. Yeah, so this is not like blowing nuclear fuel out the back or anything. So just like we have radiothermal generators or radiothermal these processes on Voyager 1 and Voyager 2, on Curiosity and Perseverance, where there's like a little capsule of radioactive material like plutonium. As it's going through radioactive decay and breaking down, it's releasing heat. And then we use that heat. It goes across a wire and generates a current. And as it generates that current, we can use that to power the spacecraft. And so like for Voyager 1 and 2, like launched in 1979 and still traveling and so far away from our planet, it's still powering those spacecraft. And for Curiosity, for Perseverance, they might last on Mars for quite a long time yet because they're not reliant on solar. But the idea with these new engines is basically kind of like an ion engine. It'll use the nuclear energy to generate the electricity needed to power the spacecraft forward. And so it's not actually like blowing any like nuclear material anywhere. The nuclear material stays inside the spacecraft the whole time. But it would generate a lot of energy. And that's the big thing. Like once it's out there, nuclear engines could really produce a lot of energy. There have been ideas of using nuclear rockets. This is not that. And so nuclear rockets are kind of scary to a lot of people for a lot of reasons. Because in those cases, it is the idea of using nuclear fuel to actually generate the amazing process of lift. And in that case, it would be blowing out radioactive material in the process too. Over here. Oh man, I love this question. So the question is, with the rise of like fusion energy being on our future potentially, things like the tokamak reactors, Like, what do we think is going to happen with fusion? And I'll tell you right now, if we actually get there, which we're not there yet, if we get there, it's going to change so much about our world. Like, honestly, like, we still are living very much on ancestral ideas of burning things to get energy. You know, discovery of fire was incredible. We cooked our food, we kept ourselves warm at night, we had light to keep predators away. Big discovery. We're still burning stuff. We're still burning fossil fuels, and there's so much more we could be doing. And even though I'm a huge advocate for other energy sources like solar and wind, we still get so much energy out of burning stuff. But if we could figure out fusion, and fission is cool, by the way, too. Like, we can do fission really well. We could build some better reactors and do more nuclear fission. We're even better now at controlling the reactions, at making sure another TMI or Chernobyl or Fukushima doesn't happen. But even then, it could. But fusion reactions are a much different process. So fission is a process where the nuclei of atoms are being split apart. And in the process, they release a lot of energy and neutrons. Those neutrons smash into other nuclei, and they smash into others, and so it gives off a lot of energy. It's also a process we have to be very careful and control. Fusion is the opposite. Fusion is when you have different nuclei of atoms that get merged together to make a new one, and in the process, it releases energy. This is happening inside of our sun right now all the time. The main process inside of our sun is hydrogen atoms, so basically just protons are being squished together to make helium nuclei, and when they do that, it releases all of that solar energy that we feel that comes to our planet. That's a lot of energy we can get out of fusion reactions if we could make it happen. And if we get there, like, we're getting closer. So I remember when I was a kid, like, it was so far in the future when I was a kid, and now it feels like it could be tomorrow. Because not only are we able to drive fusion reactions now, we put them in these large toroids, a big donut-shaped structure, basically, and we use really powerful magnets to hold the reactions in place because they're very high energy, very high temperature. And so we have to keep them controlled, and we've now been able to, like, fuse atoms together, produce a lot of energy, and sustain the reaction for minutes. For a while, it was like microseconds. Now we're getting to minutes, and if we can get to hours or longer, and also learn how to get the energy out of it. That's another big step, is how do we get the energy out to use? But once we get there, it'll change everything. Yeah?
What has been discovered about the life support system of the rainwater cycle? For example, ice-nucleating proteins and how they can condense on much warmer temperatures, keeping the clouds lower so that you can get that circulation of rainwater as compared to any other precipitation sources on any other planet other than the Earth.
So how does the hydrological cycle function, and what we're studying about it?
The biology of it. In other words, usually they talk about cloud seeding. You have to form a cloud before you can seed it. And the biology of the inland connection with clouds, it has a lot to do with ice-nucleating proteins from plants, ground cover, and also ocean plankton and whatnot. But to get inland so that you're not just depending on desalination or whatever, even in cities that normally get a lot of water, but it just goes back out to the ocean. It
Yeah.
doesn't come back in a timely manner.
Yeah, I can try my best to approach the question. The idea is about cloud condensation nuclei and how we can potentially seed clouding on our planet. Some people are thinking of doing this for issues with our climate primarily, and less for the water cycle. But
About seeding at all.
okay,
I'm talking about cloud formation, not
yeah,
cloud seeding.
yeah. So
Actually, cloud forming.
yeah.
Seeding requires that the clouds already be there.
So the idea of cloud condensation nuclei is that in the middle of those ice crystals in clouds. So ice nucleating proteins are a little bit different. Those are proteins that are basically inside of the creatures that can survive freezing. Cloud condensation nuclei can be proteins, or cells, or dust particles. They form from the Sahara Desert from dust. They form from cells in the atmosphere. There's an entire realm of biology called aerobiology, where people are studying what's up there and how far up it goes, and how these cells are an important part of creating clouds, and where this is coming from. But to get those clouds in those various places, you also do need the water itself to condense on these materials. And so one reason we can't get like a great a precipitation cycle for very, very dry places is there's just not enough moisture in the atmosphere that we could even have cloud condensation nuclei start attracting enough ice crystals. But yeah, certainly an interesting realm to explore. Yeah, very intriguing. Yeah, there's a lot happening with volcanoes as well. But yeah, I'm not really sure how better to answer the question. It is really intriguing to explore our hydrological cycle and how clouds function in general. But I don't think it's an easy process for us to replace desalinization, unfortunately, in places where there's just not enough moisture in the atmosphere to create cloud. All right, I think we're about out of time, so thank you all. All right, thank you all for coming. It's been so much fun chatting with you.